Hello DSci 2000. In this video, I will begin discussion on Unit 4, which covers advanced tools for tidy data in R, starting with string manipulation. So first things first, what I'm going to do is I'm going to open up my DSci 2000 folder, and I'm going to create a new folder in here called Unit 4. And let's go ahead and open up the rproj file. Let's create a new script. Let's save this script to the Unit 4 folder. We'll just call it string underscore manipulation. .r. So now we've created an R file. So the next thing I'm going to do is I'm going to open up my DSci 2000 folder. I'm going to git bash here, cd to the unit 4 folder, git add on string manipulation.r, and then do an initial commit. And then do a git push. We'll leave that running. Let's go ahead and do some coding. Going to the slides. In R, all strings are indicated with either single or double quotation marks. So regardless of whether you have a single quote or a double quote, these two lines of code, AB with single quotes or AB in double quotes, both refer to the string AB. This is unlike C and some other programming languages where you use single quotation marks only for single characters and double quotation marks for multi-character strings. So in R, you can use either single quotes or double quotes surrounding a string. Here are some technical aspects that I'm not going to go into much detail on, just for you to be aware of. If you need to use a single quotation within a string, you should surround the entire string with double quotes and put the single quotation in there. For example, this is the string Yang's computer. Because I have a single quotation mark that I want right here, I'm going to put a single quotation right there and surround the entire string using double quotation marks. If you're ever finding yourself in a situation where you want to use double quotation marks within a string, you should surround the string with the dquote function. What this will do is it will spit out a string that actually has those double quotes in it. If you want to print out string output, you have to surround your string with the cat function. So this here prints out the double quoted string, what is your name, question mark. Let's go ahead and demonstrate this. Let's say that I wanted to print the string banana to the console. I would use the cat function, and then in a string, I would type in banana. Let's press Control Enter, and scroll down to the console. You can see that banana has indeed been printed. There are 5 primary operations that you can perform with strings. They are concatenation, substitution, removal, extraction, and detection. This framework is how I will be presenting string manipulation in R. Concatenation is just a technical word for combining strings together. Substitution is changing part of a string and putting a different string in place of the part you took out. Removal is tossing out part of a string. Extraction is taking out a particular subset of a string. Detection is finding out whether or not one string is contained within another string. These words will be more clear as you go through this lecture. The first thing I want to observe is the following though. When you are performing string removal, that is tossing out part of a string, that is equivalent to substituting a part of a string for a zero-length string. Here's what I mean by this. Let's say you have the string yes, and you want to remove the E and the S so as to turn it to just the letter Y. That is string removal of the ES part of yes. But that's also the same thing as the following. You're taking the ES part of the string and you're substituting it for a zero-length string. So you're taking yes, taking the ES part, and substituting it for a zero-length string. That is the same thing as removing ES from the yes string. This is an important point, which I will come back to later in this lecture. So let's talk about concatenation. Remember, concatenation is just a fancy word for combining strings together. The primary function that R uses to concatenate strings is the paste function. What you can do with paste is you can give it any number of strings in its arguments, and it will combine them together into one single string. For example, if I use paste A as the first argument and B as the second argument, and I press Control Enter, what it will do, if I scroll down, is it will combine A and B into one string. By default, paste adds a single space in between the characters that you give it in its arguments. So paste A and B will give me A space B in one string. If I scroll back up, I can also choose, if I wanted to change the separator between A and B. By default, the separator is a space of length 1. I could, if I wanted to, change the separator to something else. How I would do that is I would add an additional argument to this function called sep, and if I say wanted to make the separator a semicolon, I would provide that as a string. So this is going to combine A and B into one string, separating them with a semicolon. Let's press Ctrl Enter. If I scroll down, I can see that now the string is a semicolon B. So paste allows you to concatenate or combine strings together into one string with whatever separator you want between those individual strings. If I scroll back up, another thing I could do is choose to not have a separator at all between my strings. The way you can do that is you would use the paste 0 function. If I run this with the arguments A and B, like I did with paste, and I press Ctrl Enter, what this does, if I scroll down, is it creates the string AB with nothing in between the A and the B. Paste 0 stands for the fact that there is no separator between the strings that you provided. As you might also imagine, you could also just use paste with a blank separator, like so if I were to scroll up. Let's press Ctrl Enter, and if I scroll back down, this gives me the exact same thing as if I did paste 0. Paste 0, however, is preferred when your separator is blank. Let's scroll back up and get back to the slides. If you have a vector of strings and you want to combine them into one string, you can pass the vector as an argument to paste 0 and then specify the collapse argument. The collapse argument is necessary when you are working with a vector that you want to combine as opposed to individual arguments. For example, let's say that instead of A and B separately, I had A and B inside a vector, and I want to combine A and B into a single string. In this situation, because I'm working with a vector, I would have to add the collapse argument to this with whatever separator I want between those. Let's press Ctrl Enter, and this gives me a semicolon B. So the main difference between sep and collapse is that sep is meant to work with individual strings as arguments, whereas collapse works with a vector of strings rather than individual arguments. Let's scroll back up and get back to the slides. So we have discussed concatenation. Let's talk about substitution. As an example, I'm going to consider the string banana with a lowercase b. Let's say that I wanted to change my A's to E's. Here's how you would do that. You have two options. The first option is the sub function for substitution. What you would have to first specify is what it is you want to change, which is the A, what you want to replace it with, which is the E, and then the string for which the changes are occurring. Sub changes the first occurrence of an A to an E in this situation. So if I press Ctrl Enter here, I can see that the first instance of an A in banana has been changed to an E. So scrolling back up, sub changes the first instance of A to an E in banana. I could also, if I wanted to, change all occurrences. Here's how you would do that. I'm just going to copy and paste that line of code and throw it after. And I only need to change one thing. Change sub to G sub. And the comment is now going to be changes all instances of A to an E in banana. Press Ctrl Enter. And if I scroll down, I can see now that all instances of A's have been changed to E's in banana when I execute G sub. Scrolling back up, the main difference between sub and G sub is that sub only changes the first occurrence, whereas G sub will change all occurrences. So that is how you do string substitution. Let's talk about string removal. Remember the point that I made earlier in this lecture is that string removal is equivalent to substituting a part of a string for a zero-length string. So let's consider the following example. Let's say that I wanted to, in the string banana, remove the first A in here. Here's how I would do that. I would substitute the A for a blank string in the string banana. So this removes the first A from banana. Because remember, sub only deals with the first occurrence. Press Ctrl Enter and scroll down. I can see here that the first instance of an A in banana has now been removed. Scrolling back up, Let's do the same thing, copy and paste this code, and just make a few changes to it. Change sub to G sub. Instead of removing just the first, it removes all A's from banana. Let's go here and press Control Enter and scroll down. You can see now that all instances of A's have been removed from the string banana. Let's scroll back up. So that is string removal. So let's talk about string extraction from a basic level. Let's say that I have the string Eiffel Tower, and I want to extract the tower portion of this string. Here's how you would do that. You would substitute the part of the string that you don't want in place of a blank string. So in this situation, since I want to extract tower, I would take Eiffel with a space after it and substitute it for a blank string. And let's go ahead and hit Control Enter on this. So this here extracts tower from Eiffel Tower. Scrolling back up, I'm just going to add this as a comment. So that there is how you do string removal. String removal is just substituting the part of the string that you don't want for a blank space. You could also, if you wanted to, extract substrings of a string using the substr function. What the substr function does is it allows you to extract a part of a string using position indices. Here's what I mean. Let's say, for example, that I wanted to, in the string banana, extract the first 3 letters from it. What I would do is I would type substr with banana first and start from the first character to the 3rd character. Press Control Enter and scroll down. So this does indeed extract the first 3 characters of the word banana. Going back to the slides. So the last string operation I want to discuss is string detection. Remember, string detection aims to see if one string is contained within another string. Let's go back to RStudio and go to our code. And let's say that I wanted to see if ban is contained within banana. How you would do that is as follows. Start the grepl function. Use ban as your first argument, and then banana as your second argument. Close that with the parenthesis and press Control Enter. And now let's scroll down. And you can see that this returns true, because ban is contained within banana. If I scroll back up, if I did something like grepl drum, and then banana, and I press Control Enter, if I scroll back down, drum is of course not contained in banana. So thus, grepl returns false for these 2 arguments. Let's go back to the slides. Another thing you can do when it comes to string detection is apply case-insensitive matching. Case-insensitive matching ignores any discrepancies between uppercase and lowercase. And I'll show you how to do this. Go back to your code. Let's say I wanted to see if capital BAN is contained within banana. In this case, I want R to ignore the fact that there is a capital B in ban and a lowercase b in banana, and to still match those regardless. What you do to the grepl function is you add an additional argument of ignore.case equals true. This allows you to match upper and lower case values of the same letter. Put your cursor at the end and press Control Enter. And let's scroll down. You can see here that this returns true, despite the fact that the B in ban is capital and the B in banana is lowercase. When you apply ignore.case equals true, it will match those 2 strings because it does not care about the fact that the B is capital in one and lowercase in the other. The next way to perform string detection rather than a Boolean true-false is to use indices. The way you output indices is through the grep function. The grep function is most useful when you're working with vectors. Let's go back to our code. And let's say I wanted to see, using the grep function, if B is contained in one of the components of the vector blue, yellow, and red. Let's press Control Enter and scroll down. In this case, R returns nothing because it is assuming case-sensitive matching. We do have a B in blue, but that B is capital, and we are instead trying to see if a lowercase b is in one of these 3 components of the vector. Scrolling back up, since we want case-insensitive matching here, I'm going to add ignore.case equals true as an argument to this function. And let's press Control Enter. and scroll down, what this is saying is the following. The letter B has been matched with the first component of the vector blue, yellow, red, which makes sense because blue has the letter B in it. With the ignore case equals true, it's still matching the two B's, despite that the B that we're using for matching is lowercase, and the B in blue is uppercase. So grep returns the indices where matching happens, whereas grepl just returns a simple true-false. Ignore.case performs case-insensitive matching, which allows letters to match regardless of whether they are lowercase or uppercase. Next, I'm going to discuss the stringer package. Let's go ahead and install and load the stringer package. I'm going to type in install.packages stringer and press Ctrl Enter. If I scroll down, I can see that the stringer package has been successfully downloaded. Let's go back up, and because I don't need to install the stringer package anymore, I'm going to load the package using the library function. Let's press Ctrl Enter to run that. So what we're going to do now is we're going to discuss the equivalence of these functions we have done in base R, except now in stringer. Paste in base R is the same as str_glue in stringer. So looking back at the examples we have in R, just for my convenience, I'm just going to copy and paste these lines of code. Looking back at this line of code that we had in line 2, the equivalent of stringer is str_glue. Additionally, sep will have to be changed to .sep. Put your cursor at the end and press Ctrl Enter. And let's go back down. You can see that this did the same thing as what happened when we performed paste with these arguments. Let's scroll back up and zoom out. Next, we want to discuss the equivalent of paste 0 in stringer. The equivalent of paste 0 is just str_c. I like to think of it as string combining. Let's press Ctrl Enter, and you can see in the console below that A and B have been combined into the string AB with nothing separating them. We've already gone through this one. This would just be identical to what is in the prior line, so I'm just going to delete that. This one here would be identical, except we just change paste 0 to str_c. Let's put our cursor at the end and press Ctrl Enter. Scroll down, and you can see that the vector consisting of A and B has been collapsed with a semicolon in between its components. So strc can function both as paste 0 as well as for flattening a vector into one string if you use collapse, just like you did in paste 0. Let's go back to our slides. So now we're talking about the equivalence of sub and gsub. In stringer, for sub and gsub, instead of the string of interest being at the last argument, they have to be moved to the first argument instead. So I'm going to remove banana from the third argument and move it to the first in all of these cases. And remember, sub changes only the first instance of an A to an E in this situation. Gsub changes all instances of an A to an E in banana in this situation. The equivalents in stringer are going to be str_replace for sub in all cases, and then for gsub, you will use str_replace_all in all cases. Let's go ahead and press Ctrl Enter through these lines. You can do this quickly by simply selecting this block of code and pressing Ctrl Enter. Let's scroll down. You can see here that the first instance of an A has been changed to an E in banana. In this situation here, all instances of A have been changed to an E in banana. And next, the first instance of an A has been removed from banana. And lastly, in this situation, all instances of an A have been removed from banana. So the main point I need you to get from these examples is this. Sub in stringer corresponds to str underscore replace, and gsub corresponds to str underscore replace all. Let's talk about string removal. So as I demonstrated here, when we had removed the a's from banana, you could just use str underscore replace. But there is an easier way of doing this in stringer. Instead of str underscore replace, since our aim is to remove the letters entirely, we can use str underscore remove and str underscore remove all for g sub. In addition, the blank space no longer needs to be in the arguments. Let's select these two lines and press Ctrl Enter and scroll down. So observe how these two lines are identical to these two lines. It's just that one of them uses str underscore replace and the other one uses str underscore remove. The advantage of using str underscore remove is that you don't have to specify the argument of a zero-length string. Let's go back to the Eiffel Tower example, where we extracted tower from Eiffel Tower. How you can do this is as follows. We had done this previously using stringer with str underscore replace. You can be a little more explicit about what it is you want to extract using str underscore extract. And since we're aiming to specifically extract tower from Eiffel Tower, you no longer need to specify what it is you're replacing with the zero-length string. You can just write tower instead to say that you're extracting tower from Eiffel Tower. Let's press Ctrl Enter and scroll down. And you can see tower has been extracted. The function description is simpler as well. All you're doing is extracting tower from Eiffel Tower. Let's keep going. The equivalent of subster in base R is just str underscore sub in stringer. Let's go back to our example. In this example, we had extracted the first three characters, characters 1 through 3, from banana. All we need to do is we need to change subster to str underscore sub. Put your cursor at the end of the line and press Ctrl Enter. And scroll down. You can see that the first three characters, characters 1 through 3 of banana, have been extracted. Let's go back to our slides. Let's talk about string detection. Instead of using grepl in base R, in stringer you use str underscore detect. You also have to flip the order of your arguments. Observe how the order of arguments in grepl is different than the order of arguments in str underscore detect. So in this situation, here I'm trying to see if ban is contained in banana. For str underscore detect, I have to flip the order of the arguments. And likewise for seeing if drum is part of banana, when I'm using str underscore detect. Let's highlight these two lines of code and press Ctrl Enter and scroll down. You can see here that R is telling me that ban is contained in banana, but drum is not contained in banana. Let's talk about how to apply matching with case insensitivity. The way you did this in grepl was that you gave the string that you wanted to match with first, then the longer string of interest, and then ignore.case equals true. In stringer, you replace grepl with str underscore detect. You flip the order of those arguments so you have yesterday first now. And also, you wrap yes within a fixed function in which you will specify ignore underscore case as opposed to a dot equals true. Let's go and do this in our example. Here we wanted to see if ban is contained in banana, but ignoring upper and lowercase differences. Since we are working with grepl, we must change grepl to str underscore detect. Next, we must put banana, which is the longer string, as the first argument. We will also wrap ban around a fixed function. Ignore dot case is now ignore underscore case, and we will finish this with a second parenthesis. Let's press Ctrl Enter and scroll down. You can see that R is saying that ban is in banana with case insensitivity applied. So now let's talk about grep. In the example I gave previously, we wanted to see if the letter B is contained in blue, yellow, and red. Instead of grep, what you will use instead is str underscore which. The vector of interest has to go first. Because we want to apply case insensitivity, just like with the previous example, we have to wrap it around a fixed function and then change the dot in ignore case to an underscore and put out a second parenthesis and then press Ctrl Enter. Let's scroll down. This is a 1 because it's noticing that B is only in blue but not yellow or red, and it's going to match this lowercase b with the uppercase B because we have applied case insensitivity. The last thing I want to leave you with in this lecture is that stringer is built on top of the string I package. String I package, I've had to use it a few times for string manipulation of 1 million or more strings. That's the package you'll want to use when you're dealing with that many strings at once. Base and stringer are too slow to handle data sets that are in the millions when you're dealing with string manipulation. I am not going to cover string I here, but I do suggest that if you do ever run into that situation, that you do some searching on it. We are going to be covering other tools in this class, such as Excel, Access, and Python. And I'm not going to cover string manipulation in those tools, but just be aware that those other tools do have similar functions. Now, before we end this lecture, remember to get into the habit of saving your code. Press Ctrl S. Let's go back to Git Bash. Do a commit on this. And then execute a push. And let's just go to RStudio and close it. And now we're done.